ঢাকের তালে কোমর দোলে খুশিতে নাচে মন. You must be wondering why I'm singing a song and wearing this kurta today, because this is the festive season and I would like to wish everyone out there a very happy Durga Puja and Shubha Sharadiyo. Let's start this video with today's question. Here is the question in front of you. Please pause the video, give it a try and then resume to see the solution. So let's start. How many non-positive integers satisfy the inequality this? Without directly going to this question, let's start to deal this question with a simpler example. First, let's understand what is the difference between an inequation and an equation. Now, for an equation, I'll straight away get one value of x. But in case of inequality, I'll get a range of x. That means for all the values of x for which x is less than 1, this is going to be true. And for all the values of x which is greater than 1, this inequality is going to be false. Let's go ahead with one more example. And now we can clearly see that this is a case of quadratic equation where we get two values which are x is equal to 1 or x is equal to 2. But as we did over here, can we do the same thing over here? No. We are going to again put the values x is equal to 1 and 2 on the number line, and that's how we are going to get three different sections. Now we have to deal each of the sections individually and see whether the resultant is going to be less than 0 or more than 0. Okay, let's take any value which is greater than 2. Let's say x is equal to 3. Now 3 minus 1 is a positive value, 3 minus 2 is a positive value. Positive times positive is positive. Again, a number between 1 and 2, x is equal to 1.5. So 1.5 minus 1 is 0.5, which is positive, but 1.5 minus 2 is negative 0.5. So positive times negative is negative. Again, the value that is less than 1. Let's suppose x is equal to 0. 0 minus 1 is negative, 0 minus 2 is again negative. Negative times negative is positive. So we are actually looking for the values of x for which this expression is less than 0, that is negative. So technically all the values ranging from 1 to 2 will satisfy this inequality. So that's how we get the range of x 1 to 2 for which this inequality holds. Now in the next section we'll apply the same logic to solve this question. Now let's apply whatever we just studied in the last section in this inequality. So it is 9 minus x square times x plus 1 times x plus 2 raised to the power 2, and in the denominator we have x plus 3 and x minus 2. Now 9 minus x square can further be written as 3 minus x and 3 plus x, and then I have x plus 1 and x plus 2 raised to the power 2, and in the denominator I have x plus 3 and x minus 2. This should be less than equal to 0. Now clearly x cannot be equal to minus 3 or 2. Why? Because if I put x is equal to minus 3 or 2, the denominator is going to be 0 and hence the entire inequality won't make any sense. Taking that into consideration that x is not equal to minus 3, I can cancel out x plus 3 from both numerator and the denominator, and hence I'll be left with 3 minus x, x plus 1 and x plus 2 raised to the power 2 and x minus 2 in the denominator. Now, can I take this x minus 2 to the right hand side? At this point of time, no. Why? If a is less than b, my negative a is going to be more than negative. Whenever I multiply a negative number to both the side of an inequality, the sign actually changes. Now, since I don't know what is the sign of x minus 2, I cannot take this to the right hand side at this point of time. But if I multiply the numerator and the denominator with x minus 2, now my denominator is x minus 2 raised to the power 2, which is a non-negative number, and now I can take this to the right hand side without taking any tension about the inequality. So I'll be left with x minus 2, 3 minus x, x plus 1 and x plus 2 raised to the power 2 less than equal to 0. Now, as we did in the last example that we discussed, I'm just going to put all the zeros of this inequality, starting from -2, -1, 2 and 3. And that's how I'm going to break the entire real number or real line into different sections. Let's discuss each of the sections individually. For x that is greater than 3, x greater than 3, let's suppose x is equal to 4. 4 minus 2 is positive, 3 minus 4 is negative, 4 plus 1 is positive, and 4 plus 2 is again positive. So positive times negative times positive times negative, the resultant is going to be a negative value. Then 2 to 3, let x is equal to 2.5. 2.5 minus 2 is positive, positive, positive and positive, and hence the resultant is positive. Clear? Minus 1 to 2, let's suppose x is equal to 0. 0 minus 2 is negative, 3 minus 0 is positive, positive and positive, and hence the resultant is negative. Minus 2 to minus 1, let's suppose x is equal to minus 1.5. Minus 1.5 minus 2 is negative, 3 minus minus 1.5 is positive, minus 1.5 plus 1 is negative, minus 1.5 plus 2 raised to the power 2 is positive. So negative times negative is positive, and then again we have every other thing that is positive. So if I multiply them, the resultant is going to be positive. Now x, which is for all values of x which are less than minus 2, let's suppose x is equal to minus 3. So minus 3 minus 2 is a negative value, 3 minus minus 3 is a positive value, minus 3 plus 1 is a negative value, and minus 3 plus 2 raised to the power 2 is a positive value, and hence we have the resultant as positive. That means for x greater than equal to minus 1 and 2, and for x greater than equal to 3, these are the two ranges which will give me the solution. Now, since we have an equality attached in this inequation, I am going to take all the values of x for which this entire equation is going to be 0. That means I can take x is equal to 2, x is equal to 3, minus 1 and minus 2. X is equal to minus 2, 3, minus 1 and minus 2. But I cannot take x is equal to 2, as I already discussed in the last point. So I'm just going to cancel plus 2. I have nothing to do with the non-positive integers. I have nothing to do with the positive integers. That means I'm not going to consider 3 and any number that is greater than 3. Right? So I'm just left with values like minus 1 and minus 2. And in this range, 0 is also there. That means I'm also going to consider 0 as one of the values, and apart from minus 1 and 0, no other integer in this section is going to be a non-positive integer. Clear? That means I just have 3 different values of x, minus 1, minus 2 and 0, which will help us to get a solution. Therefore, the answer to this question is option 3. I hope you liked our content. If that's true, don't forget to hit the like button, share it with your friends and subscribe our channel for more such insights.